Firebase is a large topic. You could really go into depth. What I'm hoping to do today is cover enough of all of it to get you started and get you exposed to what Firebase can do in your apps. So my name is Blaser, and I've been doing iOS development for about 3 years and some significant projects using Firebase and different elements of Firebase. So I hope to bring that insight in today, and hopefully everybody leaves with a little more Firebase knowledge. So I'm going to post the demo project on GitHub. It's one of those things where you have to build a lot of UI to show Firebase features. So I guess I can promise that by Monday or so, this repo link will be live. You'll be able to get the demo project from there. But the repo exists, just doesn't have any of the code that we'll see in it today until maybe early next week. So with that, I'm going to just jump in here and we'll get started. So it's going to be fun to do one-handed coding here a little bit.
You can probably just speak loud.
I think it'll just pick up on the mic.
I mean, I was able to project across the room, so if you just speak loud.
We'll just speak firmly, yeah. All right, so let's go ahead and look at this. So when you start out with Firebase, you can see we've got all these different platforms, all these get started. The documentation is really well written, and I've been able to solve a lot of my problems with just rereading what Google wrote maybe a couple times, and that's been really helpful. So what you'll see though is when you dig in here on products, there's a lot in here. We've got Cloud Firestore, there's Machine Learning Kit, Cloud Functions, Authentication, Hosting, so a whole host of things, Cloud Storage, and the Realtime Database. And today we're going to touch on Authentication, the Realtime Database, and then Firestore. And with a little bit of background, Realtime Database was the first offering that Firebase gave in terms of syncing data in real time between devices and the web and storing that in the cloud. And then Firestore is their newest product, and that's the one that they normally push first because they're similar, but there are some nuances. So hopefully we'll illuminate some of that as well today. So yeah, got all you need to build your backend with Firebase, depending on the app you're building. I guess we'll preface it with that. So let me just jump in here. I've got a little simple demo app here. So we're going to start off, let me just give you a little bit of a walkthrough of what this app does. So we're using Firebase Authentication to authenticate a user. And then once that they are authenticated, we have data that belongs to them in the terms of notes. So these are just simple little text lines with a date tag on them, and that's a note. And we can come in and create a new note, call this one DevFest. And if we save that, we are saving that into the backend, and then being able to pull it down here in the app. If we log out and we log back in as this person, then it's going, authenticates them in, and then is able to pull fresh data. So I'm not persisting anything in-app at this point, so it's all being pulled down fresh. So let's go ahead and start with the authentication. And to start, anytime you create a Firebase project, it shows up here in your console. So console.firebase website here. So I've got all the projects that I've been working on. If I jump in here, this is for this demo. Over here on the authentication, when you first get started, you have to tell Firebase what type of authentication methods you want to allow. So they have a tab here called Sign-in Methods, and you can see I've enabled an email password type, but there are other ways to do this, using phone. Some of these have rate limits, so you'll have to look at the pricing for like phone authentication. But you can see you've got sign in with Google, all these other third-party options to sign in with. And if you want to start using one, then in this console here, you actually have to come in and physically enable it, and then, or deliberately enable it, and then you can start using it in your apps. So these are all straightforward. The one that's interesting is an anonymous login. So let's say you have data in your database that you don't necessarily want the public to see, because if you have the address to your database and it's public, anyone can read that data. So sometimes you want data that's protected by only your apps, but you don't want users to create their own logins every time they launch your app, or the first time anyways. You can do an anonymous login that still authenticates them, and then maybe, let's say you're building a shopping app or something like that, where you want your users to engage and then convert their anonymous session into a real user account. And the SDK provides options to convert that. So you can provide a good experience for your users, have data that's behind a secure place, but then convert them when the time is right. So that's also an interesting option there. So I've got this enabled here. So let's take a look at how in iOS you do this. So this app is maybe not the best for all architectural things like building UI, but if we focus on just the things that pertain to the Firebase, we'll be in good shape there. So what I've done here is I've written a class that's called an auth manager. So this manages authentication. So the way that Firebase uses this, and this is a big caveat, so the Firebase SDK names the user as just user. So if you have a user class in your project, you need to rename it so you don't have a name conflict. So they've taken precedence on user. Represents a Firebase auth user. Okay. So what we do here is they have this really convenient method that's called addStateDidChangeListener. And this is really the way that Google recommends that this listener and the block that you pass in gets called anytime that the authentication state changes. So rather than querying on this auth object asking, for example, who is the current user, you actually use the callback listener to manage it. And I'll show you, it makes it a really convenient way to handle authentication in your apps. And so when this gets called, you have a couple options. If the user gets passed back, if it's nil, that means there's no logged in user or the user has been logged out. So this will connect here in a second. So I'm using just a notification to let other UI know that, hey, the state has changed, we need to log someone in, or we need to present the screen to allow them to log in here. And then if you have a user, then you can do other things. So let's take a look now at the sign in with credentials. So this is just your email and password. So I built this because that's the method I've implemented. If you have a third party, you would implement that a little bit differently here. So you just make a call to this sign in here, and you get a result back, and if the result is not nil, then you know that your user will be stored on that result as a user field, and then this UID field. And let me just show you what that looks like inside the console. And so if you're building a company, sorry, not company, it's been a long day already. If you're building a web app or a software that has lots of users and you may need to go in and modify users or find them or reset their accounts or things like that, then inside of this authentication, you have a list of users that you can search by their email address. You can see statistics when they signed in last, and then this unique identifier here. And this identifier is what we're going to use to actually structure our data in the database, because once we have a logged in user, we have this unique identifier, and then we can use that to structure the data and pull pertinent data to that user when they log in. So here you have options to reset their password, disable their account, or delete it from here. You can also add manual users if you're needing to create test accounts. You can do that there. So what I've done here is, and then we have a sign out here. So what happens is when, in this app, the way that I've coded it up is that when we click logout, I make a call to this sign out method, and then I don't have to do anything more with querying the user to find out are they logged in or they logged out, anything like that, because as soon as this call succeeds, it's going to call this block here and then handle it for me. So it's really convenient to just, you're off, as long as you handle the two states of I have a user or I don't, then that's all you have to do. So we can see here if I put a breakpoint in here and I log out. See, so we get it already called the logout, and now we don't have a user. So it's going to kick off this notification, which is going to then launch this login page that I created. Obviously, I don't have the fields because I'm just doing this programmatically for the demo. And then as soon as we click this, same thing, that view only dismisses when the auth state changes. So that's a bit about authentication. So the next thing, and if you have questions, feel free to stop me along the way. The next piece, though, is that user object really only returns this data here, an email address, their unique identifier, but it doesn't have anything about that user. Let's say we want to store the notes that belong to them, maybe their first and last name, things like that. So this is where we're going to start jumping into the databases. And so today we're going to cover the Realtime Database and the Cloud Firestore. And let's go ahead and start here with the Realtime Database. All right. Cool. All right. Is that the same? Yes. It sounds the same to me, but we're probably better off.
Hey,
Okay.
Quick question about the password. I mean, the authentication, that's the real basic stuff. Does Google Firebase have plugins for things like 2FA or Google Authenticator?
Yeah, so they do have, I go to this product page. So when you do authentication, they do have, you can even use third parties. Not just those providers, but if you have a token system, you can use that into Firebase. Yeah, you can do, so I think, I haven't used any of the 2FA specifically. Yeah, I know out of the box you do get a password preset if you're using the email password, and you can send emails and it'll take care of that for you. So I guess as close to the 2FA as they have is this SMS verification. So yeah, it allows users to sign in using a one-time passcode. So, and that does have a usage limit on it. But as far as built-in, that's as far as the Firebase authentication has, as far as I can count. So if SMS is secure enough 2FA for you, it's available here. If you need something else, then you might be able to make use of Firebase functions to say, hey, I've logged in, but now I need to do something before I let them in. So they'd be authenticated, but maybe your UI blocks them until, so maybe that's probably not the best use case for the Firebase auth. In that case, you might want another system that does it and then provides the token back to Firebase to say, this is a logged in user, now can we go forward. So hopefully that answers it. Yeah. Okay, so the database, there's two flavors here, the Realtime Database and the Firestore. And the main differences here, they're all technically NoSQL type databases, but the structure and how we access data and query data is different between them. So a real-time database has something like this. You have these nodes here, and I can actually export this as a JSON file, and because that's sort of how it's being stored. At least conceptually, we can think of it that way. So I created a user's field so that when that user logs in, it updates this field in the database because I need to have two types of users. The authenticated one and then the one that I store my own information that's pertinent to my app. So we've got email address and name. And the way that we populate this is here in our sign-in. I've created this method called create or update, so either one. And so I've got a real-time database version and a Firestore, Firebase Firestore version. And so what I'm doing is I'm actually taking the information from their auth record that Firebase keeps and writing it to my own custom location in the database. So I have two places to store it. I can't modify the auth object that I get from Firebase, but I can write whatever fields I need to in a separate place in the database itself. So that's what I'm doing here. And that's updating this here. And The real differences between the databases is how we end up structuring the rest of the data. So before I go there, I'll just show you what that users field here looks like. Same thing. You notice it's the same identifier, and then we have a similar set of information I'm storing about it. So that covers authentication at sort of a high level. I'd like to move now into discussing how we structure this data. So right now, these are notes that only belong to one user. But you could think of a use case where, you might have things that a user's creating that they want to share with other people who use your app. So you need data that's available outside of just one user, maybe to share it with a group. And so the places where we store that data need to be structured in a way that we can efficiently know when a user logs in, what notes belong to them, what notes are they allowed to see, and how do we keep all that in sync. So what we'll do first is we'll just dive in here with the real-time database version of this. Okay, so you can see here we have, so this will be the two notes that we've created in the app. They all have a unique identifier. Firebase can generate these for you when you push the data there, or you can use your own system, but you just have to make sure that you don't have collisions in these. That's the only requirement. So I like to use the ones that Firebase generates. When you're in the real-time database, these keys will be time sorted. So the order that they appear under this notes node is actually in time order. So they use kind of a combination of randomized and time-related things to hash these. So that's kind of a nice feature there. You can see our first, second, and third here. So when and this is good practice here, a lot of times in iOS projects, we like to move to using the codable protocol to actually deal with JSON that's coming back from the backend, right? Now with Firebase, they're passing everything to you as dictionaries, and when you write to the database, you have to write it as a dictionary, key value pairs. So the use of codable kind of breaks down there because codable is going from data to your object, and from your object to data, you have to convert it into a dictionary along the way, both directions. So when I'm working in a Firebase project, I will generally create a convenience initializer that takes in a dictionary and then can convert all the things that we get from the JSON object and turn them into our object. Similarly, if you want to write it to the database, then we have this as dictionary method that then will take all the properties and write it to a dictionary. There are probably more efficient ways to do this. The cut and dry of it though is you'll get a dictionary to begin with, turn that into your object, and then if you want to write to the database, you have to turn it back into a dictionary. So however you do that will be up to you. So what we do here is, in order to keep track of, so when I, as a user, and I create a node, I need a way to say what nodes belong to me. And in a NoSQL database, generally the rule is you try to flatten your data structure out as much as you can. And when you do that, you have duplication of data, but it's a flat structure. And so in order for this user, when they log in, to know well, what nodes belong to them, because if I have 10 users or 100 users or however many, it's all getting stored at this nodes node, right? How do I know which one is there? So we do it in two ways. One is that each node object has a string that stores the identifier of the user that created it. And so if you have a note by itself, you know who owns it. But we also have this field here that's on the user record. So rather than store all of those notes underneath the user, because if they ever want to share that with someone else, how do we keep that all organized? It's easier to say, on my user record, I just have an array or a dictionary of all the nodes that belong to me with their identifiers. Because initially, I don't need to download all of the nodes. I only need them when I need to display the page of nodes. And so I can go through and grab each individual record out of this nodes array based on the keys that belong to that user. And that's something that Firebase is really built for, is for quick read-write transactions. And so this is a good way to approach that. And you can just do a looping through here and get all the notes that you need. Maybe if they have a lot of notes and you want to do some paging, you could add some metadata in here on these notes. Say, maybe add a date field here, so then you can sort by date and then only pull certain things. So, and this is all for the real-time database. Look at Firestore, they have a lot more sophisticated querying opportunities, and so we would need to structure it this way if we were using the Firestore product. And I'll show you the comparison of that, and hopefully that'll make it clear, or at least clearer, which option might make more sense for the type of app that you're building. So now with this user record, anytime that I create a new note, I have to write it here in the notes node, and then I have to add that to my user record. And those both either need to succeed or they need to fail. So the real-time database has a okay, so this is our notes controller. So this is when we're going to create a new node. And so this first section is for the real-time database. I need to actually do two operations at the same time. I need to write the new note to the notes node, and then I also need to add that key to the user record so that I can keep everything in sync. And so a lot of the mentality you use when you're using Firebase to do this is that the client does a lot of the work to keep the data in sync. You could write functions to do this as well, and that would be so that Firebase would do these writes for you. So you have to make a trade-off about where you put the logic for these things. For this demo, I put it here, device side. But if you don't want to duplicate this logic in your web app and your Android app, then you'd want to move this into a function, which I didn't have not enough time to go over functions, but just know that that is a possibility. So they let you do these updates where you just pass in the path to where you want in the database and then the key value dictionary that you want. And you can put as many in here as needed, and then you call this update child values, and it will write all these atomically. So they either all succeed or they all fail, which is what we want. We don't want orphan notes and a user that doesn't know about them, or a note that showed up in your user record but doesn't exist in the database. And so if you delete a note, you would need to do this same thing as well to keep all that in sync. And so that flattened data structure requires a lot more work to keep all the data in sync because it's replicated. And so that's the mentality you need to get into to keep this working and not have orphan data sitting out there. Yeah, so that's what we do to create it there. And as you can see, that will then keep these two things in sync from there. So are there any questions about sort of how we're structuring this data with notes and this user record? Any questions there? Yeah.
How do you find the UI here? I mean, is it useful? I mean, it seems like it is all browser, and that would be really annoying after a while.
Yeah, and the bigger your database gets, the more data you have in here, this view slows down.
Yeah.
So yeah, so at a certain point, you will use this to architect everything, and then after that, you probably never want to visit this specific page. The other thing too is, there's no undo here, and this is basically your production database. So if you delete anything in here or modify it, it's modified forever. So I tend to not do much in here after you've sort of set everything up and you don't want to get into a...
Well, you can have a backup every day or something like that.
Yeah, and actually that is a feature that Firebase allows. You can do daily backups. There's a quota for that. So that's a handy thing too. And depending on the size of this, you can also export all this as a JSON. So if depending on the size of your database, that might be an option if you wanted to do manual backups. The same thing too if you're trying to do test data and you're building features out, and you have a set of JSON that is sort of the default, and maybe you're testing editing functions or deleting. You can then import the JSON and reset it pretty quickly to keep doing testing if you're working on a feature. So that's kind of a nice thing. That only applies in the real-time database. Firestore is not structured that way, so you don't have that luxury. And the last thing I'll say here is, if you had multiple users and they're sharing a note, then what you can see is we could end up just adding a field to one of these notes, and you add this to all of them, right? There maybe was a participants or group members or something, and you could add an array here, or the same thing like a key value pair with all of the people who share in that note, and then those would also show up on those user records. So it makes sharing a note very easily. Maybe it wasn't a feature you thought of at first, but later you wanted to add it. And if you structured your data this way, you'll be able to create those sharing relationships much easier than if the notes were actually nested inside the user object. Because now, what if that user disappears, or they transfer ownership of the note to someone else? You have to write a lot of logic to copy JSON everywhere to make sure it stays all together. Whereas you want to just simplify and have all my notes are under the notes node, and the way I get that data is by knowing which ones belong to who, and then it's staying at that level. So, okay. So let's move. I just want to show a little bit of how this works here. So this is the UI layer that actually grabs the actions. Yeah. So this presenter class is basically responsible for getting the nodes back. So what we do here is we add references to the place we want inside the database. So the high-level node is users, the child is the user ID, and then they have a child called notes. And then when we ask for that, there's different levels of observing. So this is where the real-time part kicks in. So when you look at this method here, we have observe. So this observe is for a single, well, observe here, I'm sorry, I misspoke. Observe here is actually listening for any changes that happen. And you can tell it what changes you're interested in by telling it here in this parameter. So if we look here, there are some different things here. We have child added, child changed, child moved, removed, and then value. So I went for value here because I want to know about everything. If anything changes there, I want to have all of it returned to me every time. So on value, it'll actually call this block and send you all of the data every time something changes. So that might be useful at the UI level that you need. Maybe you only need to know if something gets added, right? And so depending on what behavior you want for this real-time connection will determine what you do here and how you handle that. So I have value here, and when I get value, it sends me the whole dictionary with those key value pairs. So you need to keep that in mind. If that's a huge document of lots, and even if it's nested, it will send you back everything. So that's one thing about the real-time database, that the more nested you get, if I asked for the notes node at this level, I'd get back every note that's ever been saved in my app. That could be a lot of data. So you want to be careful about where you're placing these listeners. So we get that data back again. It's access it with this value property, and you cast it to be the type of dictionary you expect. Here I know it's going to be strings, so I can go ahead and type that, and then create that in the UI. Now the key thing though is that these listeners are, once you've created them, they exist even when this class that holds them disappears. So you need to be vigilant about cleaning up these listeners, otherwise they're all going to just keep adding and adding. So for your memory considerations, what you actually do is you hold a reference to the handle here that is that listener, and then when you go to, when this, I've got it tagged here in my DNIT. So also make sure you don't have retain cycles, otherwise this won't ever get called and you'll end up speaking from experience and many debugging. Make sure that this gets called so that you can actually purge the listener. And so then we have this remove observer to clean all that up. So that will save you time and memory leaks later. Just remember to do that. So yeah. Okay, so that kind of wraps up using the real-time database. I want to now transition to the same data model, but in Firestore, and show a little bit different approach of how you write the data there, how we structure it, and how we get it back from the Firebase. So if we look here, again, so since I'm having, when we create a node, it's actually writing to both databases, so we're keeping them all in sync. But we're doing the same thing here when we add a node. It will go in and register a node and create this the same way. But now what we want to do is compare that sort of thing. So here, real-time database, we have all the notes are being stored here on this user record to be retrieved later. Now, if we jump over to the Firestore version of this. So let's say maybe your app does have things that just belong to a user, right? So that's kind of how I've structured this differently to illustrate. So we have the same thing, our users with their UI, their identifier, their information. So in the Firestore, the way it works is it has this concept of collections and documents. And so the base level, the root of your database is a collection. And so a collection just holds one or more documents. And so this document here is one user, and then that document can have key value pairs, or it can also have its own collection of items. So what I've done here is I've actually stored the complete data from the node actually under the user. So this would be a case where you wanted to maybe have content that only belongs to that user, rather than storing it in this other place where all the content is stored. We just want it under this user. And so what ends up happening here is the differences are mostly manifest in how you access this data. So let me jump back into the code here where we've fetched that. So I'm going to switch over to my other presenter that has a similar structure. The handle for the listening is a different type. So that's one thing to note. But now what we do is, instead of using just child nodes to get there, we have a collection of users, we have a document that's keyed by the user ID, and then we have a collection, which is the node's name. And now we add the snapshot listener. And what's really great about this is that this will send you back each thing in a set of documents. So I've done this to create the notes there and pull it in. So what's nice about this is then it already knows what notes belong to the user. I don't have to go and ask the user record, what are my notes? It's connected through this collection level. But what's really neat is inside of this snapshot, you can actually look at the different types of event that would trigger this. So for example, just to demonstrate this, you can also look at, on the snapshot, you have this thing called document changes, right? So if I'm just going to do, just to show you that you can really get some nice flexibility here. So if we looked at this, you can switch on. So you get these nice things, this type here. And so you get all the different cases. You have added, modified, and removed. So the nice thing is all this is happening. I only have to add one snapshot listener. If we were doing this in the real-time database, I'd have to add a listener for child added, child removed, child modified. Here you can now attach one listener and you can get the changes here. So if your UI needs to know whether something's added or modified, to just update one UI or remove it from the view completely, you can handle all that inside of one call. So the Firestore definitely has some good advantages in that sense. We're always a little bit short on time usually in these presentations, but you can, you can really dial in with these queries and really build some robust data listening on these large collections that are very efficient. You can index them inside your Firebase console, add indices for the things that are most commonly queried for. So just to wrap up, the real main differences between these, there is a pricing difference as well, but that'll be more on your DevOps side, I suppose, that they look at that. But if you're looking for data that needs to be sort of accessible to a lot of people, the database is a good option there because you can structure your data in a way that users just have references to the data they need. If your app is more focused on documents that only pertain to the user, and that's really, you're not going to have much sharing between users, then this Firestore really out of the box provides a lot of value and keep things pretty organized for you. So again, thanks. I'll, like I said, I'll get this this code uploaded to this address here by Monday or so, and so you can dig in and take a look there. So thank you for your time. Yeah, thanks.